What's going on, guys? Let's look at this problem right here. Here this question is asking, for the MOSFET shown in the figure, the threshold voltage Vt is equal to 2 voltage and K is equal to half mu COX times W over L is equal to 0.1 milliamperes per volt square. The value of ID in milliampere is what? So here the question is asking for the ID current, and if you look at this circuit is in series. The current here is going to be like this current is going to be same here, and also here we are going to have the same current. Okay, and here you know that this is a P MOSFET and this is N channel MOSFET. Okay, now if we calculate current in one MOSFET, that's gonna be same in P MOSFET also. So we just have to look at one side, like one MOSFET current. Let's take N MOSFET. Okay, now we have to see which region this N MOSFET is in. First of all, let's go ahead and equate this one. We know that ID in P MOSFET is equal to ID in N MOSFET, since both are in series. Now ID is in P MOSFET is equal to ID is in N MOSFET. Now let's go ahead and calculate ID is in N MOSFET. So we can say both this current, N MOSFET current is this one, so that is equal to P MOSFET. Okay, now first of all we have to find out the region. There are, if current is flowing, it can be saturation region or linear region. Now in order for an N MOSFET to be in saturation region, let's look at the condition for saturation of N MOSFET is VDS must be greater than or equal to VGS minus V threshold. Okay, now VDS is what? VD minus VS. If we expand this one, this is going to be VD minus VS. Now first of all we have to know what is D and S, all these things. Now here we are looking at N MOSFET, right? This is the N MOSFET, and for N MOSFET this is going to be the D. This is the drain, and this is the gate. G is gate, this is gate, and this one is the source. Okay, so when we write everything VD, and we are looking at the position where we have voltage, particular voltages. Okay, now we have written this one. Let's continue here. So VDS is what? VD minus VS. That should be greater than VGS is what? If you expand this one, this is VG minus VS minus VT. And from this one you can see we can cancel this VS and VS. So we are left with VD that should be greater than or equal to VG minus VT. Okay, now VD is voltage across the drain. That should be greater or equal to VG, that's voltage across the gate. That's 0, because since this is connected to the ground, this is going to be 0. Let's write this one 0, and V threshold is given in the question, that is this one, 2 voltage. So this one is 2. So finally we have to have VD that should be greater than -2. But for an N MOSFET, the D drain is always positive. So if it's positive, it means it's definitely going to be greater than -2. So this is satisfying the condition for saturation. So we can say this N MOSFET is in saturation. So when we have N MOSFET in saturation, we can calculate the current of saturation. Let's write this one. So N MOSFET is in saturation. So whenever we have N MOSFET in saturation, we can use this equation: K times VGS minus VT square. So this is going to give us a current. K is what? K is given in the question, that is 0.1 milliamperes per volt square. So we can write that one here, 0.1, and I keep this one as milliampere, so I avoid unit for now. And then VGS, VG minus VS. VG is what? If I'm expanding this one, VGS means VG minus VS. So VG is 0 because this is connected to the ground. VS is this one, -5 voltage. So 0 minus -5. So that's going to be what? Positive 5. Minus V threshold is 2. So 2 square. So this is going to be what? 0.1 times 3 square. So that's going to give us 9 times 0.1. 0.1 times 9, that's going to give us 0.9 milliampere. So this is going to be the ID current. Okay, so in both MOSFET we are going to have the same current. So the final answer is 0.9 milliampere, and that's how we do this kind of problems. I hope this helps. Thanks for watching.